By 1911, James Allison's new track had held the first Indianapolis 500-mile race, and it was the beginning of a new era of auto racing and automotive innovation. As well as funding several race teams, he established his own team in 1915 and quickly gained a reputation for his work on race cars and automotive technology in general. During World War I, Allison's company suspended racing and began machining parts for the Liberty airplane engine, which became the main power plant for the US war effort. After the war, they entered a car in the 1919 Indy 500 and won.
René Thomas, who sits on the pole at 104.78 miles per hour. Wilcox starts second and wins the race, the first to be held after World War I.
But it was to be the last race Allison's team entered, as he turned his company's attention to aviation engineering. Their technical expertise and problem-solving abilities were the major factors in General Motors' decision to buy the company following Jim Allison's death in 1928. And in 1934, they created the Allison Division. Towards the end of World War II, GM put this engineering expertise to work in a new field, in transmission engineering, initially for military vehicles. And then in 1947, they produced the first Allison transmission for a city bus, followed in 1948 by one designed for off-highway vehicles. Their first fully automatic transmission for trucks was introduced in 1956 and proved extremely successful due to its excellent on- and off-road performance. By 1970, General Motors decided to combine Detroit Diesel and Allison to form the Detroit Diesel Allison Division. From there, new products were introduced, including the AT, MT and HT family of on-highway automatics. In 1987, General Motors sold Detroit Diesel and created the Allison Transmission Division. Over the next 2 decades, Allison introduced a number of innovative products, including a whole new family of transmissions and a highly advanced parallel hybrid system for buses. In 2007, the company was acquired by the Carlyle Group and Onex Corporation. And another milestone in Allison's history occurred in March 2012, when the company made an initial public offering and began trading on the New York Stock Exchange. Today, the company still has the same high standards, delivering an unrivaled combination of quality, reliability, durability, vocational value and customer service, now on a truly global scale. We have now delivered over 5 million fully automatic transmissions worldwide and more than 5,000 hybrid propulsion systems, making Allison the world's largest manufacturer of fully automatic transmissions for medium and heavy-duty commercial vehicles and hybrid propulsion systems for buses. Our headquarters are located in Indianapolis, Indiana, with regional headquarters in Shanghai, China, Chennai, India, Sliedrecht in the Netherlands, and in São Paulo, Brazil. And we have major manufacturing facilities in the US, as well as in India and Hungary, producing a wide range of transmissions for different types of vehicles, ranging from mining to military, from buses to emergency vehicles, and from distribution to heavy haul. Allison supplies to over 300 OEMs. There are sales offices in North America, Europe, Asia, Australia, South America, and Africa, and over 1,500 independent distributor and dealer locations worldwide, with customers in over 120 countries. So, what are the secrets behind this global success? Well, the real secrets of an Allison transmission are inherent in the design, embedded in the precision engineering, delivering significant value that shapes the ultimate performance. Value derived from a number of unique features. It all starts with the torque converter. Unlike a manual gearbox or AMT, an Allison fully automatic transmission uses a torque converter module in place of a conventional dry clutch. And what's unique about a torque converter is that it multiplies torque, nearly doubling the engine's torque to launch the vehicle. At ignition, as the engine flywheel rotates and the converter pump rotates with it, pressurized fluid is drawn from the sump into the converter cavity. Centrifugal force causes the fluid to be thrown out from the pump onto the vanes of the converter turbine. As the fluid comes back off the bottom of the turbine blades, it strikes the front face of the stator blades. As the stator is designed not to rotate in that direction, it redirects the fluid back towards the pump at an accelerated rate. And as this cycle is repeated, the fluid gains an extra push, and the rotational force is multiplied, enabling the turbine to transfer up to twice the full engine torque to the drivetrain. This is the vortex flow phase. As the turbine increases speed and approaches the speed of the pump, the converter reaches its maximum efficiency. At this point, the electronic controls activate the lockup clutch that instantly connects the turbine and pump, creating an efficient, direct mechanical connection between engine and drivetrain. Using sophisticated power shifting technology, engine power flows from the turbine to the output shaft through a cascade of planetary gear sets, which can seamlessly apply optimal torque to the driveline through the entire gear range. The planetary gear sets are controlled by a system of multiple wet clutches that work in pairs to implement forward and reverse speeds. With the clutches applied and released hydraulically in response to electronic signals from the transmission control module. This way, Allison transmissions deliver uninterrupted gear changes and ensure maximum engine power and torque flows to the driving wheels. Many Allison transmissions feature an integral hydraulic retarder, a self-contained unit at the output of the transmission consisting of a vaned rotor connected to the output shaft. When the retarder is activated, pressurized fluid is directed into the retarder cavity, where the interaction of the fluid with the vanes causes the retarder rotor speed to reduce, and consequently the output shaft speed to reduce, slowing the vehicle down, or limiting its speed on a downhill grade. Allison automatics incorporate advanced electronic controls that continually monitor and process transmission, engine and vehicle system data. The transmission control module receives information from speed sensors built into the transmission, providing engine, turbine and output speeds. It also exchanges data with the vehicle control network on a data link to interact with other drivetrain components, conveying vehicle management information and responding to driver requests. The driver inputs are communicated to the control module via an electronic shift selector, which also operates as a diagnostics interface. As the Allison TCM processes all this information, it's continuously learning and adapting to road conditions and mission profile, implementing advanced shift strategy for the most efficient and safe operation. The sophisticated architecture is designed to combine the values of the patented torque converter, power shifting, brake retarder, and the advanced controls, enabling an Allison transmission to deliver continuous power technology, achieving uninterrupted and efficient transfer of power from the engine through the transmission and onto the road. Continuous power technology offers distinct operational benefits in a wide range of different applications, starting with performance. The torque converter and power shifting together ensure ultimate vehicle performance, with twice the full engine torque at vehicle launch, delivering unrivaled startability, crucial with heavy loads and on steep grades. The extra torque and performance of the torque converter also provides superior rocking ability, enabling you to get out of difficult situations. And combined with uninterrupted full power shifts, it offers wider overall ratio coverage and continuous traction, giving faster vehicle acceleration where you need it, as well as the ability to conquer difficult terrain. Allison Transmissions are designed to deliver unparalleled levels of productivity and optimal fuel economy, requiring fewer gears than an equivalent manual gearbox or AMT. Delivering uninterrupted power every time a shift is made, resulting in better fuel and vehicle utilization, shortened stop-and-go cycle times. Maximum cargo can be delivered in the least amount of time. And the same operation cycle may even be possible with a reduced fleet size. We're using vehicles equipped with smaller and less costly engines. Productivity of vehicles equipped with an alternative fuel or gas engine is significantly improved with an Allison automatic. Advanced electronic controls feature the latest fuel-saving technologies to minimize the use of fuel during stops, limit acceleration, and prevent aggressive driving practice by directly controlling fuel injection, and to ensure automatic selection of optimal shift schedules under any load condition or route topography, always delivering efficient vehicle operation. Allison Transmissions are durable and reliable. Having spent over 60 years supplying transmissions for some of the most severe applications, Allison understands the rigorous demands placed upon commercial vehicles and has designed their transmissions to cope with these demands. The torque converter is not subject to wear and creates a cushion effect that reduces stop-and-go induced shock and strain on the entire driveline, prolonging its operating life. And an integrated torsional damper also protects the drivetrain from engine-induced torsional vibrations. Electronic controls constantly monitor the transmission for any operating irregularity, providing diagnostic and preventative alerts when maintenance is required. With Allison Prognostics, in combination with fully synthetic fluid, removing the need for scheduling routine vehicle maintenance, meaning less downtime and lower life cycle cost. Vehicles equipped with Allison fully automatics are easy to operate and offer superior maneuverability, with the torque converter enabling precision inching and exact alignment, making it easier to get in and out of confined spaces and tight corners. In off-road applications, the transmission provides smooth, effortless shifting and precise traction control, as well as better low-speed control. While manuals and AMTs can cause drive wheels to dig in, with consequent risk of damage to the clutch and drivetrain, the torque converter ensures just the right amount of traction for load and ground conditions, whether it's dirt, mud, sand or gravel. Without the distraction of manually changing gears, with two hands always on the wheel, you can focus on the traffic, significantly reducing driver distraction and improving safety. And with an output retarder fully integrated with the vehicle braking system, you can count on superior vehicle control in urban traffic and downhill, with service brakes only needed to bring the vehicle to a complete stop in many applications. Allison Transmissions also offer flexibility and ease of integration with the vehicle chassis and specialty equipment, with multiple power takeoff mounting provisions to drive a wide range of auxiliary equipment, as well as dedicated electronic input and output packages to fully integrate the transmission controls with the electrical and electronic vehicle systems, providing better protection of the equipment, superior performance, improved vehicle productivity. Over the years, Allison has responded to changing demands in global markets by constantly developing and improving their products and introducing new and advanced technologies. We understand how fleet owners operate in challenging and competitive markets. We know the rigorous demands placed on vehicles. That's why we design and build our transmissions for high productivity and ultimate performance, so that today, no matter what the conditions, an Allison is the automatic solution, one that you can totally rely on, because we know it's tough out there.